So 2.6.13 tells us that we have evaluations, and we know that what the expected value and standard deviation of each, we'll just call them each evaluator, make it a little simpler, of each evaluator would be. Now, what we want to do is we want to do some linear combinations with it. It tells me for like my first random variable x1, I have the expected value and the standard deviation. Now, I don't know why people always ask me like, why don't we just say like standard deviation of x1 equals 10. For some reason, that's just not common notation. So usually we'll do, and like you can write out standard deviation with the actual letters, or we'll do the sigma of x2 or sigma of x3 instead of that notation. I'm not really sure why I like that notation better. It's just not very common. Okay. Because I know I'm in the section where I'm doing combinations, it will probably be useful to find the variances first, because I know that all of my formulas use variances and not standard deviations. So like if my standard deviation for the first one is 10, the variance will then just be 10 squared. And you can see how I've written out each of the variances. I try to write everything nice and neat. Tell me my problem. So part A, it tells us that we want to make a new random variable, which will be the average. So we want to add up all three random variables and divide by 3. Now, if you are going to use our rules, you need to rewrite that a little bit. So we'll say instead of x1 plus x2 plus x3 divided by 3, we only know how to do rules that look like this. So we can say that would be the same as timesing 1/3 each one. So this is really like 1/3 times x1 plus 1/3 times the random variable x2 plus 1/3 times the random variable x3. So that's how I want to think about my new random variable, so I can use my rules. Because expected value is very easy, but the variances, you have to be a little more particular. So expected value, that would just be the expected value of 1/3 times x1 plus 1/3 times x2 plus 1/3 times x3. So we can just pull the 1/3s out, so it'll be 1/3 times the expected value of x1 plus 1/3 times the expected value of x2 plus 1/3 times the expected value of x3. So it'll be 1/3 times the first expected value, which was 59, plus 1/3 times the expected value of 67, plus 1/3 times the expected value of 72, which gives me 66. So that's my new expected value, which would be the average of all three random variables. The variance of x will be the variance of all of that, the 1/3 times x1, plus 1/3 times x2, plus 1/3 times x3. Now this is really why I wrote it out, and instead of like dividing by 3, I wrote 1/3 times, because we know how to do this. If we have a number times x for our variance, the number just comes out squared. So it'll be 1/3 squared times the variance of x1 plus 1/3 squared times the variance of x2 plus 1/3 squared times the variance of x3. Now let's figure out what that should be. So it'll be, let's just keep writing it. It's 1/3 squared times the variance of x1 was 10 squared. Plus then we'll have 1/3 squared times the variance of x2, which is 13 squared. Plus 1/3 squared times the variance of the last one, which was 4 squared. And this all gives me 95/3. So 31.66. You'll notice that I have to go through and do the variance because our formulas only work if we do it with variances. Once we've done the variance, now you can find the standard deviation. So we found expected value, we found variance, and now to find the standard deviation, that will just be the square root of the variance. So square root of 31.66 gives me 5.63. So the variance is always kind of that middle step because our formulas only work for the variance. Now for part B, we want to do something very similar, but they gave us a new formula. They said we want to use a weighted average. So they said x is 0.4 times x1 plus 0.4 times x2 plus 0.2 times x3. So notice this is going to be exactly the same as what we did up above. Expected value, you just pull out those 0.4s and 0.2s. For variance, you'll pull them out, but they have to come out squared. So go ahead and try that yourself now that we've done part A and see if you can get to the answer.